And let's go through another example of the exam. So the exam format is the same. I'm going to ask you to invent a system that uses one particular design pattern. I'm not going to tell you which one, of course. I'm going to go through an example using the state pattern today, but I might ask for another design pattern. So invent a system that uses a design pattern, briefly describe this, and then do a class diagram for that part of the system that uses that design pattern. It doesn't have to be the full system, just around that part that uses this design pattern. So this will be the first question with a couple of sub-questions to it. And then I'm going to ask you to describe two grasp patterns. Describe them in the context of that design pattern that was used in the first part of the exam, and then describe how you are using them in your particular design solution. So for today, if I'm going to use the state pattern, my plan is to use a system called JSPonies. I don't know if you've heard of it, but it's an implementation of My Little Pony ponies that run around on the screen. So I'll just write something up for that about that first, and then I'll show it to you. Right, and then something about when do we change the behaviors. So there, let me just quickly switch over to sharing the entire desktop so that I can show it running to you. So I implemented this once just because I was bored and I wanted to have, I finally found a use for the touch bar on my Mac. Of course, you need to have a pony running around on it. So I looked around and I found a couple of implementations, none of them really good. So I played around a bit and I implemented this version of these desktop ponies. And as you can see, I hope they run around, and they ever so often they say something, they change behavior. Sometimes they run, sometimes they, well, I don't know what they do. Lots of different things. So there you have it. That's what we are going to design the state pattern for today. Switching back to Emacs, so you don't have to look at all the other windows. Right, so a class diagram for this. What do we want to have in order to get this to work? Well, first of all, we need some sort of container that contains all the ponies, of course. Then we need to have each pony should be the owner of the different states. So pony has a bunch of behaviors. Like that. And they will also have, sort of, each pony will know all of the available states, and it'll know which state is active at the moment. So we're going to have actually two versions of this one. So I'm being a bit lazy. You're not allowed to do this in C++ anymore, but this is basically an array of pointers. Well, you can do it, of course. You can do anything in C++, but it's strongly discouraged. You should use list or something like else instead, but you get the idea. So this is the first one is a collection of all the available behaviors, and the second one is a pointer to the currently active behavior. Let's be consistent, like so. See what that ends up like. So that's the start at least. What we will have here, if you remember how the state pattern looks like, is that it's going to be one context class which owns the different states and decides when it's time to switch over to a new state. That'll be Pony. And we will have Pony behavior, which is in fact an abstract state. So we need to make sure that this one is abstract. And we want to annotate this and say that it's actually an abstract class and that it's part of the state pattern. So let's declare that a bit. Say that we've got a few methods in there as well. We've got one method, of course, when we enter a state. We've got one method that is basically do whatever you're supposed to do while you're in the state. And we've got one method that says that it's time to finish up and clean up so that we can move on to the next one. Like that. We might have a few other things. We might have, well, I don't know, a current animation or something like that. So we know which sprite to use. But that's a good starting point, at least. We can, of course, embellish this as much as we like, but at least we've got something. So we've told that this is an abstract class now. As you see, there's a big A here. We say that it's part of the state pattern, and this is the abstract state. And we have a few methods that each concrete state needs to implement. So we can define a few different states. I'm going to make 3 different states. One where they stand still, one where they walk, and one where they jump. So of course the difference here is that in standing there's no motion, it's just standing still, playing in the same sprite, perhaps saying something. Walking means that we are moving across the screen according to some motion vector, and jumping is, well, moving up and then moving, falling down again. So it's a different motion vector. Maybe a few sound effects and stuff there as well. Well, we might as well try and let's say we have the ability to say something as well. We want to put that into a separate class. And it will be the Pony behavior that owns a link to something. And Pony speak will have a few things. And why do I put this speak behavior outside of the actual behavior. Well, the reason is that if I do it like this, I can separate the concerns that having a behavior and saying something isn't the same thing, which means that I can reuse the speak component. No matter if I'm standing, walking, or jumping, I can use the same speak component. So that one is responsible for just speaking, and that'll be its sole responsibility, and it won't really have to worry about what other characteristics the current state has. So this is a way to lift out those things that are usable across many different states. I'll put them into separate classes. So speaking would be one. I don't know, storing to disk for whatever reason could be one that I want to use in any of the states. And whatever else, actually animating the sprite could also be something that I would put into this into a separate class. I link to them from the abstract class, meaning that all the subclasses will also have that same link, so they can all use it. This tidies up the class diagram a bit, otherwise I would have to have links from all my subclasses to this one class, and that would get really messy really quick. But here, this is actually a good starting point. This is, we have the basis of our state pattern now. We have a container containing a lot of ponies. Each pony has a collection of states, and it's got a pointer to the current state. And they have a bit of things going on as well. Each state they can speak, for example. Each concrete implementation here, I haven't written that here. So because this class is abstract and these are concrete, you can infer that all of the methods here are going to be implemented down here. So you can be lazy and not say that you are overloading them or that you're actually implementing them here. You could also repeat the methods, so enter, execute, and exit methods. If you repeat them down here, you're making it very explicit that these are implemented here. If you have a deeper inheritance hierarchy, it might be relevant to say that this method is implemented here, the others are still postponed to some other class further down. But if you don't write anything, you leave it up to the implementer to read your design diagram, and they will probably interpret it as that because these are concrete, I of course have to implement all these methods, so I will. Right. So describe the classes. Not much to do there, just a brief description of which classes that are part of the state pattern. One is the context. Let's see, there should be. Never mind. I'll do it the ugly way instead. There should be a way to put these French quotes in there somewhere, but I keep forgetting where they are on the keyboard. So the pony is the context in the state pattern. What is its responsibilities? It owns a collection of pony behaviors. That's the currently active state. Pony behavior. That's the abstract state. And what is the responsibility of this class? It provides an interface. That's its sole responsibility. Then we have the different states. Each of them implement one state. And what else? In particular, then, that the execute method would be the one that um, contains the really important stuff that you the execute method is where you're actually running the state. So every time if this was a game, for example, you would have a game loop, and once uh, every 60th of a second or something like that, you would hit the execute method. So they would update their coordinates, update their sprites, roll a dice if it's time to say something or not, and so on. So that would all be done in the execute method. In the enter method, you would probably load the sprite, you would reset all the timers and everything. And in the exit method, you would clean up whatever mess that you've made after yourself. So those are the main classes that we have in the state pattern. Let's describe the others as well, just to be complete. So pony speak is one single line of speech that a pony behavior can say. It's actually the pony that says it, obviously, but they can say different things in different states. So that's why we connected it to the pony behavior instead. And then the pony container. The next, so these two are the first two bits, or actually it's 3 bits. You describe the system, briefly describe the system of your choice, so that I can see how you're thinking, what type of system you're looking at, and where does the requested design pattern come into play. The class diagram gives me an understanding that shows that you have understood how to apply that particular design pattern into a concrete system. Describing the classes means that you actually put a rationale behind it. Otherwise, I have to make a lot of guesses when I read a class diagram, and you don't want me guessing at your design. So that's why you describe what you've done. You show in the description that these are the classes that are part of the design pattern, and these are surrounding classes with the following responsibilities, so that I can follow along and understand your line of thinking. That makes it so much easier for me to understand, and so much easier for you to convince me that you've understood things. The next bit is to write a bit of pseudocode for this. So I'm going to ask you to write some sort of code. It can be in a programming language that you know, or in some sort of mock programming language that just explains that you've understood how to implement the design pattern as well. So in this case, what we would like to do is that we would like to have code for when we create different pony behaviors. And we would like to have code for when we switch from one state to the other. I don't know, let's call it Java just to get some syntax highlighting. And the create method, what's that going to do? So this is when we create a new pony. We would like to get a list of behaviors from some sort of configuration file. that's in some sort of init file format. Get all the behaviors that this particular pony should have, and then based on this we can start creating them. And as you see, I'm mixing programming languages something horribly here. This is very much not something that you would be able to execute. So this part is C++, or actually C with an array of pointers. This is C++ for each. Well, there is such a thing as a C for each, I think, in C++ these days, but definitely not on a double pointer like this. And then we throw in a lambda function, an anonymous function here, which I think, well, this syntax looks like JavaScript, but the idea is this is very much pseudocode then, but the idea is to show how things happen. It's not about making something that will actually compile, but something that explains to me that you understand the mechanisms behind, and then throw in whatever syntactic sugar that you find is most comfortable for you. So I've got a list of names. I need to transform that into particular behaviors. So let's do that. I would like to have a new pony behavior done. Or a pointer to one. Of course, I can't call a constructor on pony behavior because that's an abstract class, right? So it's that won't work. So I'm going to, I don't know, let's try in a factory. Based on the behavior name. So that one, this factory class, which isn't in the class diagrams, I would have to go back and add that. So I would add that into the class diagram and a description of it. This class is only responsible for knowing what different behaviors there are and what names they have, so that it's able to create a new stand, walk, or jump, in this case, based on the string it gets. And then let's see, add it to the behavior collection. Something like that. So this would be the crate. I get a list of behavior names from some sort of init file, and I, for each of them, I call my factory and create a pony behavior, a concrete class for that, and I throw that into my array of behaviors, my collection of behaviors. I would probably want to set something as being the current behavior. So let's use the first one as our default one. And that should get us going. Now we have a starting behavior and we know which the collection of all the behaviors that we have. When we want to change behaviors, let's try in a method for that. Still in the pony class, because that's the context class, so that's the one that needs to understand how to switch between the different states. And it's going to take a new string or a string. And based on that one, well, I could probably run around in my collection of behaviors and find one that matches this string. So let's do that. Like so. If I found something, I can obviously do something with it. And what do I want to do? Well, I want to clean up the current behavior. I want to set the current behavior to be the new one. And I want to tell this behavior that it's allowed to start up whatever it needs to do and load whatever it needs to do. Like so. Which I probably should do up here as well. So that it's got a chance to load things there as well. Those are the two main methods in order to get the state pattern to work. One to create everything and get things started, and one to switch between the behaviors. Now, I'm going to carefully duck the question on how do I know that it's time to switch to a new behavior? That's a whole discussion in its own right, and I'm not going to go in there for this example. You, of course, would have to do it in your exam, but I think it'll be messy here, so I'm not going to do that. I'm also not using, as you see, the method, whatever method that would call the execute isn't here. That one is sort of not really relevant, or well, it's relevant, but it's not that really interesting to show. Switching behavior is important, showing that I do an exit and I switch to the new one and I do an enter, but that I somewhere along the line use the pointer, my current behavior, and I call execute, and I do that regularly. That's not something that's um, really fascinating or interesting to show. These are the two methods where you show that you understand the state pattern, the creation and the switching. The rules for when to switch isn't also, that's not really part of the state pattern as such. So we can leave those leave those. Um, we should probably go back up and add the factory since we have it here. Um, since I have this factory method here, or factory class, we should probably add it to our class diagram as well. Um, we do that. Here. There, just to show that we have this pony behavior factory, and we'll probably need to add that into the description as well. So it gets a behavior name, and then it creates an object based on one of the concrete implementations under pony behavior. So that's well and good. This is the first part of the exam. You, as I say, will have more time. You have more or less a week, or you have a week. So you can spend some time to embellish this description. You can write a bit more in the description. You can write a slightly better description of the classes, and you can make sure that you actually cover everything that should be covered in the pseudocode. But as an example during a lecture, I think this is sufficient. So the grass patterns, that's the next bit then. Let's see, creator and information expert are the two patterns that I randomly selected for this example. And if we are first just going to look at the state pattern and see how they use these two different, we can say that pony, or rather we can say that the context class is a creator. Let's do that in bonus then. Of pony behavior, or the different states. The abstract state is an information expert about the interface to provide. The concrete states are information experts on what it means to be in that particular state. What else? Well, the pony is, so the context class is also an information expert about what the current state is. So that is more or less the two grass patterns, creator and information expert, in the perspective of the design pattern itself. And if we look at the implementation as a whole, or the system as a whole that we've described, many of these things are the same, of course. So pony is a creator, or actually pony behavior factory is a creator. Pony behavior is an information expert of the interface. And so on and so forth. It's just a matter of going through the different classes and looking at what should this class be an information expert on. Is it a creator of some sort? We could say that someone of the stand, walk, jump, or the pony behavior would be creators of the pony speech. Pony is an information expert on the list of behaviors that a certain pony has, and it's also an information expert on which state is currently active. Pony container is an information expert on um, Pony container is an information expert on all the ponies that are available, and so on and so forth. Let's say I'm not sure I understand your question. So I will be uploading this to Canvas afterwards, so you can see that, and you will see the questions there as well. I published them last time. Sorry, that's the Swedish version. Here we are. So this is the format of the exam later on, and I think they are old exams from last year are there as well, but they are all in Swedish because this is the first time I give this course in English. But something like this will be there as well. I can publish what I have for you. So the questions are, as I say, invent a small system, describe it, create class diagram about it, and describe how you've used the pattern and what classes and methods and roles and responsibilities and so on, and then write pseudocode for it, and then describe the grass patterns and use the system from task 1 and describe how the different grass patterns are used in that system. Which is basically what I've done, right? So I've more or less followed the brief of the exam. So I'm not sure if there's very much more to say. I can of course continue working and just writing down basically what I said about what the component container is. It's an information expert. Pony is an information expert on a few other things. These different concrete states are information experts on what it means to be in that particular state, which is basically what I wrote about the generic state pattern as well over here. And with this, you've more or less covered what should be in the exam. Just a matter of putting in more details for your sake. So I'm going to stop the recording now, not just pause it.